All right, so good morning, everyone. So I hope that all of you have a fantastic week. Today we're going to work on chapter
Now
10.
you the choose, now you the control your schedule. You check out for available classes anyway, for time.
All right. So making sure that you're gonna, if you have any questions to ask, just let me know what it is. And if we have no questions, I'm going to let us know the schedule, the rest of the schedule for the entire semester. And after that, I will definitely going to let you know the final exam date and so on and so forth. Okay, is that good, people? All right. So, and I have some concern about the office hours. I will be there from 12 to 1 p.m. Should be 1:10. We have more questions to ask. And I believe that's really, really important that we're gonna have to talk to each other and then have certain things that we're gonna deal with. So today we're going to focus on chapter 10, and then after that, we're gonna have the next week gonna be at 11, and then on 11:20, so that would be chapter 12. So we're gonna have 1 week of, and then we'll come back to it. We're gonna have this the second exam review and the second exams, and then the final weeks will be on December 12th, 18. Is that good, people? Is that good? It's actually just uploaded like a few minutes ago. So I was like a little busy talking to some of the students. So I apologize for that, Jennifer. And chapter 10 is, I will upload to chapter 11 and 12. There's a lot of typos and certain homework problems. And it's definitely going to be on a certain chapters. And chapter 10 was pretty okay, but when it comes to chapter 11, then we have to know how to compute like a big calculation using a calculator. I will show you how to do it. Just don't panic. If you just give yourself some tries. If you can make it on the first try, you can start it with the second one and so on and so forth. I think that you should end up doing it. So I also graded like classwork 4. I'll be grading classwork 5 at the end of the day. I've seen people who have some trouble from chapter 9. Okay, so if you don't know how to do some probability regarding proportions, just go to office hour. I'll be there, still waiting for you guys to come. And then at least you're gonna go there and say hi to me. If you're not that, available between 12 to 1 p.m. so you can schedule another hour for it. So I'll pretty flexible, but my schedule is packed, so we can have some conversation on Sunday, or maybe some conversation on Monday after 8 p.m. I believe it's so from 8 to 9. So I'll be there for the office hour if you want, or maybe a certain time that you feel favorable along the way. So I really want you guys to ask questions during class. Have any concern, just let me know what it is. Okay, so if we have no more concern, then we're going to start with chapter 10. So this is going to be a chapter that focus on the second exam. And of course, the focus is definitely going to be on chapter 10, 11, and 12. Okay, so especially 10 and 12, those two chapters are critically important that you're going to see them on the second exam and the final exam. So regarding for chapter 10, so this is where we're going to do the hypothesis testing using a single sample. There are some analysis that test on 2 samples regarding 2 populations, or 3 sample regarding 3 population. We can also test like 10 sample regarding 10 population along when you compare them. But we're not gonna do some matrix stuff like that. It's basically really complicated. So we're going to stop at 2 samples on chapter 11, and then we pretty much end the entire course semester. Okay, so starting from chapter 10, so this pretty much similar chapter to chapter 9, except for the fact that instead of we testing on like the confidence interval where we knew a certain concept, like build of the estimations, the range estimation based upon the margin of error. So this is what we have done from chapter 9. So for this chapter regarding chapter 10, so we're going to start with the hypothesis testing. So this is definitely going to work on the, hold on a second, just let me. Chapter 10, so it's going to be a hypothesis testing. And there are actually two of them. So one of them is called the hypothesis testing for the quantitative data set. So this is the first part that we're going to go over. So this is 10.1. And so this is going to be on the quantitative data. So the difference between the quantitative data and the qualitative data. So quantitative that we have the mean and standard deviation, and the qualitative data that we have proportion. So those are two different stories. So the first thing that we need to know is the fact that we're going to understand this picture I have drawn this picture like more than once. It's on chapter 8 and then chapter 9. And one of my favorite students actually says that, well, I mean, I draw this more than 7 times. And of course, I would continue working on it until chapter 12, and then pretty much the end of the story. So we have a big population with N, and we definitely don't know how big of that jungle is. So it can be something. It can be something really big population. So that reason why we require statistics, because we only work on a small sample, and it's very cost efficient that we're gonna deal with about 30 samples, 35 samples, 100 people. It's rather than the entire population itself. So we want to know what characteristics that the population is going to hold based upon the sample information. So we just do it one more time. So I draw another pictures. So this is what we call a sample, right? So we're gonna shed some light, collect a certain sample, some data set, and then you want to know what it is, right? So this data set is going to give us the small n, right? The small n. All right. So this sample is going to give us two key statistics. So one we call the X bar, and that is what we have for the sample mean, and another one we call the S, which is called sample standard deviation. Okay, is that good? Usually regarding the sample that we use English letters, we use X bar to represent sample average, we use S to represent sample standard deviation. So we learned it from chapter 9, and then we continue using it for chapter 10 and chapter 11. Okay, regarding the population that we're going to have the big letter M. So all of those are the Greek letters that represent the population parameter, usually not known. So we don't exactly know what they are, right? So those are just something that we try to get the final answers from the sample. It's trying to get some little piece of information based upon two sample information that we have right there. Okay, so from chapter 9 that we're going to estimate the average, right? So this is where we're going to compute a range based upon a margin of error and so on and so forth. So in this chapter, we're going to do different things. So we want to throw in a certain hypothesis, right? Throw in hypothesis to test, right? There should be a few hypotheses. Just want to making sure that we understand. This can be one more. It can be more than one, but of course on the exam it should be one hypothesis, and then you want to test it, right, and verify if that is true. I mean, and of course we can't really know exactly what the data set is going to behave, like what exactly the average looks like, but we can see the bounds, and it's not going to be something that we're going to spend like so much time working on the type 1 errors, the type 2 errors. So there's a lot of concern along when we read the chapter 10 summary, you might figure out that there a certain point that we want to work with with Taiwan errors and Tai 2 errors. So this is those fundamental error that we committed to. Okay, but we're not going to spend too much time working on it because of the time consuming. I just want you directly, I just want you direct you told you exactly what we have on the exam. So before that we're going to understand that it's the chapter 9, 10 is basically come from a same chapter. Okay, so this is going to be the thing that I'm going to draw them out in. And then I just use the chapter 10 perspective, chapter 8, chapter 9 perspective to came up with the analysis. Okay. So this is what we have for the big mountain that we have learned. And of course, it can be either the Z or the T or any model. Okay, it doesn't matter which one. So assuming that the second exam average, okay, the average that we have will be around, instant, 85, maybe whatever it is, okay, 85. So this is what we have for the X bar, and I'm going to put it down right there. So the average will be equal to 85 points. Okay, so this is a fixed number coming from the class perspective. I don't know. This is just my assumption. It might be wrong. It might be yes. So what I'm going to estimate. So I want to use this our class estimate to predict the population average. I mean the entire Math 213 average for the second exam. Right. So assuming that the standard deviations that we have was something that I would say we call STD, would be around 6 point whatever it is, right? Now, and then we sort of like developing some range for the population average. So this is what we have. We can't do that from chapter 9. So assuming that the average that we have, of course, I'm not going to compute it. You can do that actually. Let's say we're going to go for 95% confidence interval. So we can actually deal with them for a number of samples. So we have 44 members in the classroom, right? For instance. And then I also built up the range calculations for this. So I would say, so we can easily do that, correct? So we can also use whatever it is. Still remember the T models, and then we can just build up the range for the mean and something like that. I will tell you exactly what it is. It's just literally make no difference since people are actually using this method to deal with a two-tail, and that's perfectly cool. Okay, so the range for the population means would be equal to the X bar that we have was 85 and plus and minus. So I believe plus and minus the T times the standard deviations over radical n. So we might want to look at the charts for the information for the t-test, and of course the degree of freedom that we have is basically equal to 43. So if you don't have these numbers on the chart, so we can use 40 or 45. I don't think that really matter to us that much. So assuming that we can use 40, right? So the degree of freedom is 43, but we don't have 43 degree of freedom, so we have to take 40 into account. So assuming that we use the confidence interval is 95%. Okay, 95% confidence interval. Okay, and that is 0.950. Okay, is that good, people? And then I'm gonna take the degree of freedom, in this case, 95, and then go all the way down to 40. So that was 2.021. Just want to making sure that we understand how we're going to get this part. And so we got 2.021, and then we just take that number 2.021, and then we multiply by the standard deviation, right? And this is what we have learned how to compute the range. So this is what we call the margin of error. Multiply by 6, and we divide it by let's say the radical 44, and then we should be able to get the range, the average for that. Okay, so we divide it by radical 44. And then we can compute that. We can take the calculator, or we can use GoGo. I think that works a lot faster. So 85 and minus 2.021 times 6 over radical 44. And then we got the answers 83.17, right? 83, around that. And then of course that we're going to do the same thing. We should be able to get this one is equal to 87.
Isn't the sample standard deviation?
Yeah,
The
it should
6?
be, yes, the 6 should be the sample standard deviation because this is the information that I got from, assuming that this is the second exam average and then the standard deviation that we developed. And this is, and of course this has to be from the sample. We just want to making sure that we got this part, and usually we don't get anything for the population. That's the main thing. So this is the average for the population. I'm sorry, for a sample as well. And so the population that we should have the range, which is about between 83 and 87. Of course, is slightly decimal of, so that should be 83.17, and this should be 86.83, something like that, very close to it. And this is what the range looks like. So now instead of we doing so, now we want to use different method. So we call throw-in method. So I'm going to throw in a lot of hypotheses. I want to check if the class average is actually more than B minus, for instance. So can I say something like that? Can I just claim that this hypothesis is correct? So the mean is greater than 83. I'm sorry, 82. I'm sorry with that. Can we say something like that? People? Oh, come on. We have 35 people during the weekend. Would you say so? Can we say that the average that is bigger than, that is more than 82? Yes, because the range is actually bounded between 83 and 87. So even the smallest number of the bow beat 82, right? So this one is good. We put check on it. And now I would like to ask you another question. Like, can I say something if the range is bigger than, let's say, I think B was between 85 to 87. No, I'm sorry. It should be 86, something like that, right? So can I say that the class is actually greater than 86 people? No, very good. Why not? Because that is a very important information that we trying to get, and why we cannot say that our class average, no, it's not actually not a class average, but some class average is actually not beating up 86. It's not, we cannot claim that the mean is greater than 86 because the mean can be 82. I'm sorry, the mean can be 83, can be 84, can be 85, right? So we have no information about this range. So this is why I told you. This is what I told you, right? It's the smaller the range, the more accurate, the more information that we got. So between 83 and 87, so the mean can be any numbers, correct? So we cannot say that the mean is greater than 86 within these regions. Are we good? Can we also say that, for instance, I want you to test if compared to the last year average, can I say something like that as well? So let's say the mean is less than 84. Yes or no? Yeah. Yes, Sahir? No.
Yeah, I mean, how does that even make sense? Because isn't 86 still within 83 and 87?
No, because yeah, that is a good point. This is counterintuitive because we sort of thinking that the mean is between 83 and 87. So any number that bow between this range going to be valid? The answer is no. We have to think of it oppositely. So what happening for that? If they want to test on the mean is greater than 86, right? So let's say 86 will be around this corner. Okay, so how is that possible? I can say the mean is basically bigger than 86, whereas the mean can be 84. So 84 cannot be bigger than 86. The means can be 85, so 85 cannot be bigger than 86, right? Does it make sense a little bit? Because the mean,
Oh,
the average can be any number between 83 and 87. So we have no clue what's going on within this range, right? So we can't just say, well, what happened if we test the mean greater than 84 or less than 84? That still makes no sense because the mean can be 85, right? So 85 beat 84, that makes no sense. The mean can be 87, 87 that beat 84, that makes no sense. You claim that the mean is less than 84. So within the, I would say this region, so we have no clue. Does it make sense to us a little bit? Wouldn't you,
I don't
the
know. I don't know
means,
how to feel about this.
it's
'Cause
still not,
if-
I right. Wouldn't the means greater than 82 also not work? For mean equal to 87, that is a good question. Let me just do that one more time. Can we say something about this? Can we write them down? Can we claim that the mean is less than 88 from one of the questions from Keener? Can we say that? Is it yes or no? Yes, correct. Because the greatest number, the biggest number from the average that we developed from the confidence level was 87. So the biggest number is 87. So I can't guarantee you 100%. I'm sorry, not 100% because we take 95% confidence interval. So I can guarantee you a 95% chance that the mean is actually less than 88, right? Does it make sense a little bit? No?
Yeah.
The biggest number is 87. So if the biggest number even less than 88, so that basically makes sense. Correct? Come on, give me some thought on it.
Yeah.
Exactly. So we can definitely, and we become a lot confidence that we can become a lot more confident to say that, well, any number that is about between the tail, I mean, the tail is right here. Oh my goodness, I have so bad drawing today, to be honest. So let me just do that. Okay, I think the color doesn't really hurt your eyes. Yeah, the means greater than 1 is basically makes a lot of sense, but it's not really helpful. If you test on the mean greater than 1, I would say, how's that possible? I don't think that the average should be greater than 1 point. I don't think that the class average less than 50 points for that reason. And how do I
Wait,
choose? Yeah, how do I choose? Because no, this is something that we develop the hypothesis based upon the information that we have right there, right? So assuming the exam 2, we have 44 members, and then the average was 85, and then the standard deviation is 6, and then we of course take 95% confidence interval, and after that we're gonna develop the from chapter 9, we calculate the range. Remember, the smaller the range, the better estimation will be. This is what I told you before, correct? So, and then we're going to do a certain hypothesis. Of course, you're not going to test on the means greater than 50 points because I like 100% sure that our class average should be greater than 50. But I have seen the class, the math 213, that average was 43 from the math department record. But of course, it's never happened in my class, and hopefully it's never happened in this class either. And hopefully I just keep my finger crossed anyhow. Yeah, 43, the average was really, really awful. But I don't think that we should test around, around 50 points or 60 points from the math department, for 213. So I would say it should be around like B minus or maybe C plus. So let's say, can we say something if the mean is greater than 77 based upon this analysis? The answer is yes, because 77 is basically about it from the acceptance regions. Yes, question. Any other concern?
so basically any numbers between 83 and 87 would not work, but any number outside of that range works.
That's it. That's
Okay.
it. Yeah, we finished chapter 10. That's it. We just call it a day. You guys are going to have a wonderful weekend. Take care. I'm just kidding for that. So this is what we call the undecided region or undecisive. I'm so sorry for that. Okay, so what does that mean by undecisive region, people? So when we do in a certain like the mean bigger than that or something like this, so we not going to accept it. Okay, and about these two regions, I would say those two regions. So this is going to be on the left tail. Oh, I'm running out of space. Can I write something like that? So this is what we call the left tail region. Okay. So the left tail is going to be something that we call the alpha for alpha. And the alpha, which is the significant level. Okay, significant level. It's pretty much the similar to the confidence interval. So let's say if we are 95% confident, okay, so this is for true toe, and then the alpha should be 5%. Does it make sense a little bit? So in other words, we only have 5% chance to accept the hypothesis. Are we good? Does it make sense a little bit? So the alpha is just, it's just like if you take alpha equal to 5% change. So what does that mean? We're going to face 5% risk that our report going to get wrong. Okay, our decision will be wrong. So this is what we call the type 2 error. But you're not gonna like go deep into it like for a certain concern for that. Let's say we take the alpha equal to 10%, which means that the confidence interval will be 90%. So we're facing 10% risk that our report is completely gone crazy or maybe just not going to do well. Correct? So it's just think of it like the vaccinated, like the vaccine Pfizer's like 95% effectiveness. So we still have 5% chain of risk. So this is pretty much the same thing that we have right there. Okay, so the alpha, we're going to have 5. So let's say we take the confidence interval is 95%. So this 5% chains going to be a thing that we are allowed for that error, for the critical error, okay, or which is called significant level. Okay, and then this 5% chance is something that we can utilize to either accept or reject the hypothesis. Exactly. So if we take this is 2 tau, so each of them should be 2.5%. Right? If we only test on 1 tau, then we should be doing differently. So there are 2 types of tests. Okay, the first type, which is called a 2 tau test. Okay, so the 2 tau test is generally something that we call the different. Okay, so we can only test on the different, not the ego, because the ego going to be on the no hypothesis. So we test on a different. Okay, so we just call it different. And then we also have the one tail test. One tail test, we just really concerned about either is greater than or less than, and that's pretty much it. The difference, you have to consider both of them on greater or less than. So this is we call one tail test. Okay, so we're going to have the size greater than. So this is going to be on the right tail. And then we also have the size less than, which is on the left tail. So what are the difference between the right and the left tail? So we can definitely going to look it up on this. So let's say we test on this means greater than 82, right? It's on the right tail, and the mean is greater than 86. So this is going to be on the left, on the right tail. If we test on the means less than 88, so it should be on the left tail. Are we good with that? Are we good? Does it make sense a little bit? Okay, so, and of course that we're not going to test on the mean greater than 50 or 60. I guarantee you like 100% sure that is true. Not for like 95%. I would say for 99.99%, that's still be correct because the average that we have on our class is really high. Okay, assuming our class is a non-biased factor, non-biased sample, and of course that we couldn't do it that way because so if we only consider our class as a perfect sample, that doesn't work. Maybe I just take like a few people from this class and a few people from that class, and then we just compute the average and standard deviation along the way, so that would be a little bit more objective. But of course, it just is just one example. I just want to tell you what it is. Okay. All right. So we're gonna develop some hypotheses. So I want you to do it for two-tail, basically, and the two-tail will be slightly different. So let's go for, we want to test, right? So we're gonna do part 8, test if the mean is greater than the average for the population. It's greater than, I'm sorry, less than 88, okay, less than 88. So, and most of us say yes, right? Most of us say yes, of course, because it went out of the bounds. And very likely that should be the yes question, but we have to check them, right? So let me just copy and paste first. So instead of testing less than, we test on different, because we want to go for the two-tail test first. The confidence interval that we have done was on two-tail. They're actually one-tail confidence interval, but we skip that part, unfortunately. Okay, so we test on different. I want to check if the average is different from 88 points. So coming from the same questions right here, okay, coming from the same questions right here. Okay, so let me just do that real quick. Okay, and test if the mean is different from 88. Okay. All right. And then if the question asks to test on different, you can just use chapter 9 hypothesis. I'm sorry, the confidence interval, we can say yes at 95%, or the alpha will be equal to 5%. Okay. So the 5% change here we call significant level. Okay. Usually if the confidence interval is 90%, 95%, and 99%. So the alpha that we have should be 10%, 5%, and 1%. So let's take the alpha equal to 5%. So now we're going to develop the hypothesis. So we call HO and HA. Okay, so the HO is something that we call no hypothesis. Okay, and HA is something that we call alternative hypothesis. So those two are very, very different, in the sense that the no hypothesis is something that we try to get rid of. This is not true. Okay, we're not going to utilize this. Okay, and HA is something that we try to test on the sample. Okay, so the populations that we're going to do, it will be the mean different from 88 points. So we're going to just put it down to average. Okay, different from 88. Is that good, people? So we always have to write of what we are trying to test on a second hypothesis. If you ask me why do we always have to put it on a second line, but why not the first one? So because the chance that we can accept this hypothesis is very, very low. We only have like around 5% chance. And of course, we know the answer yes, because based upon what we have done from this part of a sample, the answer should be yes. But we want to deal with that using different method. Okay. So the mean is different from 88, correct? So on top of that, you just put out an equal sign, because that's going to make you a lot easier to read. Okay, so even if we test on a different, greater, or less than, we still have to put the equal sign for the first hypothesis. We call no hypothesis. So the no, NULL, the no hypothesis means that this is something that we're trying to reject. We're trying to get rid of. So we can never accept that the mean equal to 88 because we have no clue. Okay, there's no way they can say that the mean is equal to 88 based upon the information that we get from the sample. Okay, but we can check if the mean is different from 88. So the good part is also a really bad part about statistics, is that we can try to reject as many things as possible, but usually that we cannot accept anything statistic. That is something that is weird, but it's true for every single cases. It's just like it's just like sociology. When you have a certain debate, so we can't say one perspective is good and the other one is bad, but there are a lot of concern, like we have to weigh from one factor to another factors, right? So there's a lot of things going on. So the things that we're going to compete will be coming from the T hypothesis, right? So the T test going to be the form that we have to use for chapter 10. So we're going to take the X bar. Okay, we take the X bar and minus the means. Okay, subtract the average. Okay, and after that, we divide it by the standard deviation. Does it look very familiar to you guys? Maybe you've seen that before or somewhere else. And then multiply by
the Z test.
Yeah, the Z term, something like that. But we're changing the syntax, right? So instead of we having the Z equal to what do we call from chapter, I would say from chapter 8, so we're gonna have the X bar minus the mean, and we divide it by standard deviation, right? And then multiply by radical n. But because we definitely don't know what the population standard deviation looks like, so we cannot use the T. So the William, the guys from England, is British, and then he came up with the T test, so he was just replacing the sigma by S, and then the T can be worked for a very small sample. Let's say we ought to take 5 students or 6 students, that's still working out. Okay, so perfectly. But now we're going to change that to the S. Remember, he just have to replace the sigma by S and multiply by radical n. That is a good question that some people ask if this standard deviation is coming from the population or sample. On the exam, it have to be coming from the samples standard deviation, because we don't necessarily have this kind of information. So, and then the next part, we just have to plug in the values and then the value that we have. So the X bar was 85. And then, so what is the means? So we don't really have the information. This is something that we're trying to assume that the mean is different from 88. So we're going to take 88. It's coming from the null hypothesis. So we're going to subtract 88. Okay. No, we can't assume that so I mean, you can assume that the null hypothesis should be true, but realistically speaking, we can never accept it for that reason, because the average should be about between 83 to 87. So the null hypothesis is something that we use to counterpart the alternate hypothesis, because the null hypothesis usually that's coming from the 95% confidence level. And then, so this is very ambiguous. So that reason why most statisticians, they can just use the equal sign to represent them. There are actually some both that you greater or less than for that reason. But on the alternative hypothesis, something that we're going to maintain along the way, and then we have to, if we reject the no, then we're going to accept the alternative hypothesis. Okay, so and then, but we can never accept the null hypothesis, to be honest. So that is the reason why most statisticians never use the word accept for the wrong thing. This is the thing that we're trying to get rid of. This is the thing that we're trying to prove wrong. Or in other words, the null hypothesis is something that we're trying to disprove, just a better way of saying it. Okay, so let me just move on to this part. Did it answer your question, Dennis? It's still being clear, because we can't just like learning all of this. I'm gonna post one article. It's not me written it, but it was someone else, and it was no. We're not trying to prove the no. We're trying to disprove it. Okay, that is a good question. I've never seen this question before. We are trying to disprove the null hypothesis. So that if we disprove it wrong, if you can prove it wrong, so the alternative has to be right. Yeah, I think that makes sense to us. Yes, questions?
Yeah, so when we reject the no, we accept the alternative hypothesis,
Exactly.
right?
Mm-hmm.
But what about when we fail to reject the no?
Then we have to reject. Then we have to reject this guy. Then the the assumption that we make was wrong, so we cannot deal with that. But that is a good point. That we would say fail to reject the node, meaning that we have to reject the XJ. I will let you know what it is. But we don't want to really bother that much to look at the null hypothesis. I would say if something happened, then we're going to accept XJ, and something doesn't happen, that we're going to say reject XJ. So I feel like that's going to be a little better of doing statistics. I mean, maybe I just oversimplify things by ignore the fact that sometimes we have to disprove the null hypothesis so that we can prove the other thing. But thinking of that ways might be a little bit harder to do the math. No, we can't really say that the null hypothesis is the best measure. It's just the corresponding to the alternative hypothesis, and it has to be because the part that we're trying to disprove is huge. That belongs to 95% confidence interval, right? And then the part we're trying to prove was smaller, so which is 5%, and which is why that we always have to put the HA on the bottom compared to the top hypothesis. So we can't usually write anything about a null hypothesis, so it doesn't really affect us. Sometimes people just put the greater than or or equal to or less than or equal to. There are multiple ways of writing null hypothesis, but for the alternative hypothesis have to be followed to a certain test that we have made right there. Okay, so the hypothesis that we're trying to prove have to be put on the second hypothesis. So this is what it is. All right, so let me just wrap this up, and then we're going to have a little discussions at the end of the class. You actually want to get this done better, but usually most theoretical perspective. So when it comes to chapter 12, we tell you something like that. Then we try to prove if the contingency chart. This is something that we developed from chapter 7 or chapter 6, right? If they are independent and not independent, something like that. And then, of course, the assumption that we're trying to say theoretically, they are independent, but the thing that we're trying to prove is that there should be dependence, right? So there are certain things going on, and there are certain things that we definitely cannot prove for the null hypothesis. Because this is not the known information. We have no clue whether if the mean is equal to 88, but we can prove something if the mean is different from 88. So that's going to be a different story. So the only thing, if we can prove this by disproving the HO, so that's going to be a thing that we have to work out. All right, so I believe there's a little arguments, and sometimes it's really, really hard to perceive this. But when it comes to later chapter, just hold on for a second. When it comes to a later chapter, I will show you why that works, okay? So we divided by the sample standard deviation will be 6, and then we multiply by radical n. The radical n was radical 44, correct? Are we good? Are we good with that? Oh my goodness, I feel like so bad, maybe not answering your questions appropriately, but it's because of the time consuming. So I will basically going to answer your question later on. If very, very intuitively speaking, like the null hypothesis is something that we cannot say the mean equal to 88. We don't have enough information for that. So this is why we have to disprove it. I think it's still not clear. Yeah. Yes, we're going to have this competition after class. So let me just compute this first and see if that works. So we take 85 minus 88 over 6 times radical 44. Are we good with that? So we're going to get the answer, which is negative 3.31. Okay. Any concern with this calculation? Any concern like how we're going to compute this? I believe it's very, very important to know. Oh, come on, guys, please. Yeah. we only have one lectures for this. Yeah, but we definitely going to deal with that for later chapter, right? Are we good with that? So -3.3. So now we're gonna go for the critical values. Okay, the critical value we call TC. So what is the critical value? The critical value is something that we found on the chart, and it was pretty exactly the same way that we found from the confidence interval. And the thing that we did it from this part was 2.021. So let me just show you how you do it for the two-tail area. So we're pretty much doing exactly the same thing. Okay, so let me just copy and paste for that. Okay, and let me just go down here. All right, so the one bad thing is that because we don't really have the degree of freedom on the charts, so we're going to use either 40, 45, it's up to go. It's really up to you on the exams, right? And it's good to go. If you use one of those, and of course I'm gonna give you full credit for it. Yes. And then, so now we have to go for two-tail. The reason why two-tail, because we test on it different. So we're gonna go for, so the alpha is 5%. So the two-tail areas is basically 95% confidence interval. And then that's going to give me the answers as 2.021. Are we good? Any concern for that? So I have to keep the TCs as a negative numbers because the T value that we computed was negative. So the TC have to put the negative sign in the front. Right. So let me just point it out. The TC is negative because the T was negative. Are we good with that? Yeah. I mean, if you want to test on the right toe, that's perfectly cool because this is two-toe test. It doesn't matter. We just make that positive and then just keep TC as positive number, but because the calculation that we have was negative part, so we have to go for the left toe. Okay. Yes, the C represents confidence interval, and this is pretty much the value that we have right there. And then the ports that we have to compute the degree of freedom, and the degree of freedom is 44 minus 1, and that was equal to 43. So we don't have 43s, then we're going to use df equal to 40. Okay. And then I believe I know it's somewhat really hard to accept the fact that I'm going to use the 40 as the degree of freedom, but it's actually what it is. Okay. And if you ask me, can we use 45? The answer is yes. Come on, just like a different number. It doesn't really make a lot of difference at all. So the final step that we need to so does alternative hypothesis dictates which type of test? Yes, it is. So that is the thing that we have here. So we want to make sure that the mean is different from 88. And this is what we're trying to develop on a two-tail test, right? And it's have to be on a two-tail area. And then when you look at the alpha, so that will be 0.05 for the two-tail. Yeah, this definitely makes sense. Alternative hypothesis is going to be the thing that we're trying to prove by disproving the null hypothesis. It seems like it's really, really crazy stuff, right? In fact, we cannot say the mean equal to 88 point, okay? We cannot say that. So, but we can try to disprove it so that we're going to accept another one, right? So does it make sense a little bit? I'm not trying to confuse you, but we're trying to disprove the wrong thing. So if you disprove the wrong thing, the other thing has to be correct. Okay. Okay, this is really complicated statement. It's a really complicated statement. We cannot prove that the mean equal to 80 for sure. I mean, this is not correct for sure because we don't have the information, but we're trying to disprove it, and then we're going to say the other one has to be correct. And then we're gonna go for the testing. So we have different way of doing it. So we just trying to make sure that it's have to be either on the left and the right tail, right? So it's have to be on the proven region. So if that's fall within the undecisive region, then we cannot say anything. It have to be fall of like around the tail, either on the left or the right. So we good to go. Okay, are we good with that? So what's going on for that? So we have to look at the left using this critical values. Like so, critical value that we got was negative 2.201. So it's negative 2.021. So I apologize for that. And then, so what do you think? Where's my negative 3.31 goes? Level rate. If it's fall within the rates here, then we cannot say anything. Right? Because this is what we call the undecisive region, right? So what do you think? Where negative 3.31 goes? Left. So we have to be right here. Are we good? We have to be on this area. Is that good, people? Have to be on this area. Let me just pen this a little bit. Correct? Yeah, so if that's on these areas, what should we do? We're going to say yes. We're going to say yes. Are we good with that? Are we good? So negative 3.31, this should be around here. I'm sorry. Does it make sense? So remember, the critical value is going to be something that we're going to put down to test the T. The T will be coming from statistics, okay? Coming from the sample information. The T value, and then the TC is coming from the not a confidence level, but the alpha. It's 5%. Yes.
Wait, but isn't it positive on the chart?
Which one? Yeah.
The 2.021. So why did you make it
Yes.
negative?
Oh, because I put it right here because the T that we compute is negative. So we have to.
Oh, so you just switch the sign?
Yeah, just change the sign.
Okay.
Yeah, I mean, you can make it positive so we can test on the right. So we can just take 2.021s and then we have to make that positive 3.31, just test on the right tail because it works for both tails, right? The difference, it doesn't matter either on the left or the right. It still makes sense for that reason. But we just have to take the absolute value for this though. Okay. Is that good, people? Is that good? Is that clear or not clear? Oh, come on, give me some feedback. This is almost the end of the course. Yeah, so what are we going to say? We're going to reject HO, right? Yeah, what does it mean by rejecting HO? Meaning that we just disprove it. Oh my goodness, now I just disprove HO. And then if we disprove this has to be right. On the bottom, we have to accept HA. Are we good? Is that good? How does we disprove it again? So it's just anything that fall between the tails, either on the left or the right, we're going to say yes for HA. No, it's actually not becoming the new HO for that reason. It's just something that we're going to claim that the hypothesis is correct. The HO is we call it no hypothesis. It's just not the thing that we trying to prove, but the thing that we're trying to disprove. So we can definitely going to say that the average should be different from 88 points. Okay, it's something that we can utilize this to say going from that perspective. Yeah, in fact, we can use this information by chapter 9, right? We compute for the range that was between 83 and 87. if I put in some score, let's say different from 82, the answer yes. Different from 81, the answer yes. Different from 90 points, the answer yes, and so on and so forth. Okay. Okay, let me just repeat that again. If the TC is actually bigger than the T in the, I'm sorry, or maybe the T greater than the TC in absolute value, just looking at the amplitude for that, right? So we're going to reject the actual, and then we're going to accept the actual, because that falls between the accepting regions. Is that good?
Yeah, what are we taking the absolute value of T, right?
Oh yeah, because I will tell you
Okay.
why. I will tell you why for that reason. I will tell you why. Then I'm gonna make the summaries, how we're gonna reject and accept it. Okay.
But absolute value of T would always be greater. So,
Yes,
right?
we're going to play around with some example. To be honest, this is the hardest part to understand for statistics. I will definitely gonna let you know for the next example. Is that good? We
Yeah.
usually
Okay.
we're going to do the summary right here. I can do that first. Okay, acceptance summary or reject summary. Of course, I'm not trying to make you memorize it, but I feel like it's always good to have those summary being pointed, and then so that you don't necessarily have to be, thinkings or confusing and all of this. So if we look at, because the sign, the T can be either negative or positive. So I feel like it might be really hard if we don't use a chart to look at the left or right tail, correct? So what's going on for that is we're going to use the absolute values for T if the T was less than the TC, okay? Oh, I mean, it's not only for a single thing. It's not only for T, it works for chi-square, it works for exponential function, it works for the Z, it works for anything. Okay, it's not only for a single test that we have right there, the t-test. So if the T was less than a TC, what happening? We're going to reject HA. Are we good? Oh, come on, give me some response. Are we good with that? Well, you just write on there, reject HA, I understand. Okay, and then, I mean, we're just looking at the amplitude. We're not going to concerning either it is on the left or on the right. Come on, this is like, I don't want to be like, you draw so many pictures on the exam because it's going to be like a lot of things, but understanding pictures is actually really important. If you want to go further in statistics, I believe it's better to have a picture with you. So if the T is greater than the TC, just like that, we're looking at the amplitude, right? So 3.31 is bigger than 2.021 for sure. So we're going to accept HJ. Accept HJ meaning that we're going to reject HL. Oh no, hold on a second. Is that good? Yeah, that's I feel like that's will be like a lot of better. So let me just draw out a picture. If you want to understand why, right? But you can completely ignore it after you understand me. Oh my god. Whenever I draw like a mountain, there's always be like something that I have trouble with. Oh my goodness, what does it look like, people? You look at, so this is what we call a TC, okay? And this is what we call for TC, right? And anything that is about it, so if the T, right, if the T was about it, if the T is right here, right, if the T was right here, okay, so this is negative TC, right? If the T is right here, what happening? So we're going to have a T less than TC or greater than negative TC, right, in the absolute values, right? So it's basically going to rejecting XJ. We reject XJ. Are we good with that? Are we good? Is that good, people? Oh, come on, give me some response. The human emotions. Oh my goodness. Okay, fantastic. So if you have something perfect, if the t was greater than, right? If the t was greater than, so either the t is gonna be on this side, right? So the t will be, let's say the t was, so the tc was 2, the t gonna be the tc was -2, and then the t was -3, so 3 is still greater than 2, right? In terms of the attitude, and it's also work for this side as well. If the t was greater than this, so what happening? So we're going to accept it, right? Does it make sense a little bit? Yeah, the TC is a number, is a certain number that we can figure out on the chart, and it is we call the critical value. But what does that stand for? Oh yeah, so the T, the C, which is called a critical values, in other words.
Đi nào à? Đi ra. Đi nào à?
Oh, so sorry with that. It's got mute. Is that great? The critical value coming from the significant level perspective. Okay, so let's say we take 5%. So the critical value going to be different from 10%. And then T also depends on the number of sample that we have from the data set. So if we have 35 samples, that should be different from 20 sample, and that should be different from 10 sample. Okay. That's fine. Is happening. So the TC is based upon the alpha, okay? The alpha and the degree of freedom. Is that good, people? Is that good? So we can try it out with some example and see what it is, okay? All right. I would try that with question number 4. It's gonna be a long day for you guys, and it's, oh my goodness, you're gonna, I'm going to make you suffer for, I think, for the next 2 weeks before Thanksgiving. I'm so sorry that this is what happening that we have to deal with before the exam. Okay, so I hope you understand. Oh my goodness, that's suffering, especially this weather. My room is super hot right now. I had to turn out the heat for a little. And it's not my room, it's my sister's room actually. So now we're gonna look at that sample. So we have the random sample of n equal to 30. So how do you know if that is on chapter 9 or 10 or something like that, 11 and 12? I will definitely going to tell you exactly what it is, right? And then when we're gonna test them, maybe 1 sample or 2 sample. And usually the question is going to be saying, do the sample data provide strong support, like confidence intervals? It's going to be a different story from chapter 10, right? And sometimes with the alpha equal to 5% or 2% or 1%. Okay, so sometimes the alpha equal to 2% is not found on the chart. Can we use 1% instead? I'm so sorry. So I'm going to change the question to the alpha equal to 1%. Okay, because we don't have 2% on the chart. It's just looks like it different for that. Is that good? So we just take the alpha equal to 1% chance. Okay, so now we're gonna go for X bar. So the X bar that we have here was what? The X bar was what, people? The X bar was.
Isn't it the 48,700? Wait, yeah, 48,722.
49,000. 850. Let me tell you why. And sometimes if we want to know the difference, yeah, let me tell you this. After the n, after the number of sample, it's gonna be the x bar and the sample standard deviation. Let me try to repeat that again. So we're gonna highlight a question, the random sample is 30 accounting graduate, right? And blah, 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 so on and so forth. And then result it. So this is the average coming from the sample 30 that we took. Okay, so this have to be the x bar. And then of course, this standard deviation has to be the S. Okay, so the question confusing, right? If the question gives us S and X bar, so there's no mistake that we make on the exam. So that should be very clear for that. But the question doesn't give us that information. So we're going to figure out that if after S, so we're going to have the X bar and the sample standard deviation. Is that good, people? Is that good? Yeah, so you gotta be careful. And now, how are we going to look at the hypothesized mean? So this is not given. This is not given. It usually after the keywords like higher than, or less than, or greater than, or smaller than, or lower than. Okay, so all of that are different from. So this is going to be the hypothesized mean. Okay, so we want to test if the mean is greater than 48,772. Are we good? Is that good? Okay, so this is what we're going to test at the alpha equal to 1%. I'm so sorry, we couldn't find alpha equal to 2% for some reason. So we can only use the alpha equal to 1%. Okay, so now we're going to develop the hypothesis. So the HO and HA, HO and HA, okay? Is that good? You have to do that. If you skip those two steps, you're gonna lose some points on the exam. So don't forget those two steps, okay? This is very important. Just write them down, HO, HA. So the HA is something that we're going for the greater than. It's something that we're trying to prove, right? And we're gonna have the means greater than 48,722. And then on top of that, what should we write? We're going to write them down the means equal to, so we have to put the equal sign, okay? 48,722. Is that good? And of course that the mean should not be exactly 48,722 because we definitely don't have that information, but this is going to be something that we're trying to disprove. Yes, the HO is always equal to, but to be honest, there were some books that they use less than equal to. If you study like theoretical statistics, because the HO and HA, they going to make up the entire hypothesis, right? And then a lot of people might ask me, hey, if you put the equal sign, what happened for the less than, right? And you know, there's a lot of things going on, but I just want to make our class simple, right? So the first, we're gonna put the equal. The second, we're going to use and read the information that we have in the questions. Like higher than, you put greater than, the alligator side facing to the M, I mean the U, whatever it is. And then if you have a lower than, so the alligator side facing to the numbers. Yes, questions up here? Yes.
There is no such thing as X bar is greater than like that. Like they're not gonna ask a question like that, right?
X bar.
You know how like let's say higher than 48,722, so X bar greater than 48,722.
No.
Then no, right? Okay.
No, it's always the hypothesis always do with the population, because we have this usually we have a sample information to prove, or maybe we're trying to get a certain thing on a population. So on the hypothesis, all we have to write out with the mean greater than or less than or different from. On the top part, you're gonna write out equal to. Okay, so I believe that's gonna be something that we utilize for the exams. And Got it. Yeah, it's actually really important. So we have this is one tau, correct? Because it's greater than the test on the greater side. And make sure that you're not going to put the X bar on the hypothesis, because if you put the X bar on the hypothesis, we're going to get it wrong. We can't test on sample. The sample is something that we have the information already. So we know for sure that the average for 30 people was 49,850 and the sample standard deviation was 3,300. So this is something that we have the information already. The information that we don't know is if the mean is greater than 48,722, and this is from the 2010 national average. Oh my goodness, I took this question a long time ago, like 11 years ago. So it might not be a lot of fun like to play around with this data set statistics. So the next part that we're going to write down the T, right? So we have to compute the T. This is the statistic score that we got from the question. So we're going to take X bar, what was 49,850, subtract the 48,722. Are we good with that? Are we good with that? And then we divided by the sample standard deviation was 3,300. And then we multiply by radical n, which is radical 30. And then we're going to compute that in the calculators, so we can definitely have got the answers. Minus 48,722 over 3,300 times radical 30. Is that good? So we got 1.87. Any concern? Any concern? Okay. Now, are we good with that? Would you make me proud, at least up to the step? No. Okay, very good. But if you say no, I still really want you to put it down there. Okay, I'm gonna copy this one really quick for that. I just want to make sure that you guys know how to compute it. Come on, I think copy to Google. The Google's actually give us the faster calculation anyway. So yeah, let me just try it with this. Okay. And after that, what should we do next? We're going to, no, we have to look at the critical value first. The 1.87. So we have to look at the critical value. So don't forget a critical value. So we need to compute degree of freedom. So remember, we only compute the degree of freedom for the t-test. So we have 30 member, we take away 1, so we get 29 degree of freedom. So we have to use a chart. This is what I told you. Every single chapter requires us to use some eye drop, like before we read the chart. Okay, you have to read the chart, chapter summary, that's really important. And the chart sometimes really small, so we're gonna zoom in a little bit. And then we're gonna go for, which one? For 29, I believe, correct? So we're gonna go for 29 degree of freedom.
So we have to calculate the critical value before the conclusion.
We don't calculate, we read it. We have to read it. Yeah.
Oh, okay.
Yeah, we have to read that. And many of my people said reading the chart is a lot of work. Only one person can finish this the whole course without reading the chart. You know how to compute a t-test, because I give him like the form for that. He just do it on calculators, but generally we have to do it. We have to read the chart, and then the chart that go for the one tail area, because this is one tail, right? And then we're gonna go for 0.01 because we take the average, which 0.01. Yeah, so, and then we have to go for degree of freedom, which 29 because we have 30 sample, we take 29 degree of freedom, correct? And then the TC that we got is 2.462. And then we look at this. This is positive, so the TCs have to be positive. Are we good? Are we good with that? Yeah, so now we sort of like forgot what it is, so we're gonna use char, right? If the T was less than TC, what happened? What should we do? We go into reject XJ, because if the T were less than TC, right? If the T was less than TC, it should be on this region, correct? On positive part, right? So we reject XJ. Is that good? Oh, come on, give me some less than TC.
Where you said if the value of the t-test is less than the critical value, you reject the null hypothesis.
No, we
I
reject
mean the
the
alternative.
yeah, alternative hypothesis. I mean, if the T less than TC, we fail to reject a no, and then we reject the alternative hypothesis. So is that good? People?
Yeah.
Yeah. On the exam, you don't have to show me like 1.87. I mean, if you show me like that, I appreciate it, but you don't have to, right? Because I know the fact that 1.87 is less than 2.462 for sure. Okay. But if you can show me this on the exam, I know that you pay attention to the class, there's a lot of things going on, you're a good person, good students, yeah. And this is the thing that we're gonna put that reject actually. And again, we cannot accept HO. There's no way you can claim that the mean equal to 40,722. Okay, so there's no way. So all we can do is just fetch reject. Is that good? Okay, so we can't accept it. We cannot accept the wrong thing. We can't. The only thing that we can prove, the only thing we can do is just disprove the null hypothesis, so that we're going to prove XJ. But if you cannot disprove it, you cannot say it is correct, right? Something is not wrong. It doesn't mean that it has to be right. That is so crazy. There's a lot of things. There's a lot of jokes around the corners. Go back to the diagram real quick. Oh yeah. So this is a diagram. So let's say the TC was something that we found was 2.462, right? Assuming this is 2.462, and then 2.462, and then 1.87 should be this, right? Around this, so we have to reject J. Make sense? But can we say that it's the most accurate? I wouldn't. No, we can't say that though. There's nothing. Okay, that is a fun story to tell. Right? There's nothing right to say. It's not right to say it's accurate. There's not such a thing that we call accuracies in statistics. So we just have to test it from different angles. So for instance, that we want to test if the mean was greater than 48,722 from 2010 national average. But if you want to get more information, let's say if the mean was actually greater than 49,000, so it might be a little better information compared to 48,722. But if we can't prove it, so I would say the mean greater than 49,000 is more accurate than 48,722. Okay. And of course, it just depends on the angle that we look at from when we develop the null hypothesis and the eternal hypothesis. Okay, and so I would say it's the correct decision that we make. But if you ask me if that is the most precise decision, I would say no. There's nothing I would say like 100% true for this. Even if we reject XJ, but we're still facing like 5% chance that this will be wrong. I'm sorry, 1% chance. I'm sorry that the alpha is 1% chance. So this is only correct for 99% confidence interval. So even if we disclaim that the mean is greater than 40,722, but there's still 1% chance that this is true. Okay, so that's going to be the whole story for that. Anyhow, I feel like that's going to be the things you do. Do we need one more example? Do we need like some more practice so we can know how we're going to get those things done?
I have a question, Professor.
Yeah.
So the answer for this question is basically just to reject HA and
Yeah.
fail to reject HO.
Fetch rejection. Yeah, you can just put it down on top of the hypothesis,
Oh, okay.
on top of the hypothesis that we have earlier. Yeah.
Thank you.
You're very welcome. Yes, yes. Let's go for question number 2. I mean, the math was pretty okay, but the concept was really terrible to pretty hard to understand. Like, and why this is this and not that, and so on and so forth. Let me just go for one more example. Hold on a second. Okay. So we're gonna do the same thing for that. We're going to put down the how many credit cards do you have like undergraduate? It was 3.1. So this is what they have for the record. And of course that we're going to test this out using the information that we got. And so we're gonna look at the ends. So the end was, we look at 20 undergraduate, right? So we have to look at 20s here. Okay, and equal to 20. Is that good? And then, and of course, the sample mean was what 2.6, but after n should be the x bar were 2.6. Okay, is that good? And then the sample standard deviation is 1.2. Okay, and then now we're going to test if the mean was, the keyword for that was less than 3.1. So if the question does not give us the alpha, then the alpha will be 5%. Let me just repeat that again. If the question, most likely, most of the report they do not provide with the alpha is 5%. It's always be the standard level. It's just like 95% confidence interval. We always have to take that. Okay, so if the question does not give us the alpha, you have to take the alpha to 5%. Okay, are we good with that? Are we good? So now we're going to look at the HA and HO, correct? What should we write, people?
Wait, isn't it one tail because it's less than?
Less
So
than.
that would be the alternative hypothesis.
Very good. You have to put a second node on a second line. So the mean less than 3.1 on top of that.
And then the null hypothesis would be the opposite. So greater than or equal to.
I would suggest just put equal to, just make it easier. I mean, you can put greater than or equal to. It should be the opposite for that, but I feel like, you know, making the class a little easier to put equal to, and that's perfectly okay. But usually you're absolutely correct. So we can put greater than or equal to as well, because they have to be the opposite. So, and this is one tail. Are we good?
Oh, I meant like the other way, greater than or equal to, like together. Is that, can we not do that?
If you want to write something like greater than or equal to,
Yeah.
that's perfectly correct. This is what I usually prefer people to do, because they have to be the opposite. Because you have, if you reject this guy, you have to, if you accept this, you have to reject another. But you know, just make my class simple. I just put the equal sign. It's because it's always correct. This doesn't matter for the null hypothesis. So most of these statistic books, they use equal signs, but including our books. But if you study some theoretical statistics, you have to put the greater than or equal to, actually. But anyhow, either ways, I'm still give you full credit for it. Okay, and then we're gonna go for the t. What is the t values, people? We're going to take the x bar was 2.6, correct? And we subtract 3.1, right? Because this is the mean equal to 3.1, right? I mean, we just subtract this guy from the actual, right? And then we divide it by people, 1.2 times, and what is the answer for that? Yeah, what's the answer for that? Oh, come on. I mean, yeah, no, it's divided by 1. I need the answer, you know. I need some help from you guys. I know it's Saturday. It's almost like I let you out early. I let you out at 3:10, something like that. So just help me out with this calculation. Very good. So you're gonna get this one is negative 1.86. If nobody helped me, I'm gonna let you out at 4. Think about it. You want to get out early? Just help me out with this. Okay, Daniel is giving perfect answers. Yeah, I take that decimal as well. Is that good, people? And after that, we're gonna go for TC. TC is based off the degree of freedom. In this case was 20 minus 1, so always 20 minus 1 for T only. Okay, for T only for T. And then the alpha is 5%. And how can we read that part? Okay, fantastic. And we got its part. So let me just copy and paste. Just want to making sure that we have no space for the post. Yes, it is. Okay, so have to be going for 1 tel, and it's have to be the 19. All right. Okay, so I'm gonna make you eyes suffer a little bit. Oh my goodness, that's a little too small. Oh my god, somebody read that? I don't think you can. So I just don't want you to post like twice for it, but anyhow, let me just go for it. So this is 1 tel area, right? These have to do with for 1 tel. And then we're gonna go for degree of freedom equal to 19. Right? So yeah. The TC, so we're gonna go for 19 degree of freedom, right? 19s. And then the alpha is 5%. So 5% is here. And we got the answers is 1.729. Are we good? So we have to put a negative side because the value that we computed, it has to be on the left tail. So we have to put 1.729. Are we good? Yeah. And then finally, that we're going to look at the absolute value, because remember, how do you take the absolute value? Because the t that we computed on the left tail, so it have to be greater than the TC, right? Absolute value is greater than that. We only look at the amplitude for that. So the amplitude is going to tell us that 1.863 is greater than 1.729. So what can we say? People? So we're going to accept it, right? Okay, is that good? Oh, come on, Euler. Accept it. Let me just go back to the notes here. Right, accept it. To be honest, when I look at those two values, I just always do it in my head. I always like making the mountains charts. No, in absolute value.
Wait, I have a question because the absolute value of negative 1.863 is positive 1.86,
Right.
and that falls outside of the region of
That's
when
correct.
we draw the critical value.
Mm-hmm.
Yeah, it's better to see it with graph.
Yeah. Oh, you want to draw a picture like that? Oh, come on. I would be very happy if you do that, though. Yeah, because people plan to skip the pictures. In the past years ago, I did not let my people just skip it. I feel like, hey, do the picture. It's gonna be beautiful. You're gonna draw some mountains on the exam, you know. And then they refuse because they feel like having a pictures might be a little bit confusing. But anyhow, so negative 1.863, it should be on the tail regions, correct? So it's when it's come to the tail region, then we have to accept H, reject H1. Are we good? Right here, that's the ecstatic J. Whatever is on this region, right? Is that good?
Yes.
Okay, fantastic. You say yes, and I'm going to move up to the next chapter, 10.2. Are we good with that?
Professor,
Do
I
we
have
have to
another
explain
question.
it?
Yes, please. Oh my goodness, I ignore it anyways. I'm trying to.
Wait, no, you could go ahead.
Yes. Question?
Oh, yes. How do you know if it's one tail or two tail? Can you go over that again, please?
One tail is testing on the greater than or less than, so that'd be one tail. And two tails testing on a difference. Yeah.
Okay.
Just
Thank you.
like that example. So the only thing that makes them different is that we have to look at the two tail areas and the one tail area. So that's going to be the key difference. Yeah. Equal, no, different. The difference, we cannot test the equal side. The equal is basically too broad to deal with. We don't have the data set. So we cannot say something equal to, it's just like we have the sample of our class average was 85. So that would be completely really biased to say that, well, the average for the entire map 213 is equal to 88 points. So it is just complete bias. We don't have that, but we can say if the mean is different from 88, I would be like that would make more sense. Yes.
Also, when we're like, reading the problems, we know that it's a hypothesis testing problem because of like the keywords, the convincing evidence and stuff.
Right. How come the last example I didn't do the absolute value? Because they are both positive. If the t's were positive, then we don't have to take the absolute value. If the t was negative, then we have to do the absolute values. No, the other one. So which ones? That one. Yeah, because we draw out a picture. That makes sense. If you don't draw the pictures, then we're going to take the absolute value of the t was greater than TC for sure. If the T was greater than TC, we're gonna accept HA, right? Yeah. But I draw the pictures because I draw the pictures, so I feel like it's easier. I can just know that negative 3.31 is on the left of negative 2.021, and this should be good to go. Right, so the T was greater than TC, so we're going to accept HA. You can also do that on the hypothesis, right? This one, sure. Are we good? Yeah. So that one is. We can also do that though, instead of drawing pictures. 3.31 is greater than 2.021, so we're going to accept HA, reject HA. Okay. Any concern? Are we good? Can we see an example for two-tailed test? Yes. Yes, please. No, I would say no because you can make me so sad by not helping me doing the math. Yeah, of course, I was kidding for that. Let's go one more example for two tails and let's see. Yeah. And we have a lot of distractions, right? And this is the questions that concerning about two-tailed test. Okay, so assuming that the distraction to the teenage boys working on independent tasks was 4 minutes, I would say like for me was half an hour, so maybe 30 minutes or 1 hour for that. I don't know, but 4 minutes was a little bit too small. And let's think of it. And then we're gonna go for n equal to 25. Are we good? So we're gonna put that down to n random sample equal to 25. Are we good with that? And then, although the sample size was not given in the chart in the article, so it's supposed that the mean was based on 4 minutes. So the 4 minutes that we have are going to be the X bar. So this question was slightly different. So we're going to put the X bar first before the end, right? You're going to read the question and then you identify the X bars here. And then after that, we're going to look at the sample standard deviation. So the sample standard deviation that we have was 4 minutes. Oh, I'm sorry, 1.4 minutes. So we're going to put that 1.4. All right. And then we want you to test if the mean was different from 5. So once you test that the mean was different from 5 minutes. So this is what we're going to put them down. The mean is different from 5 minutes. Are we good? And using the alpha equal to 1%. Is that good, people? Is that good? Yes. And then, yeah, usually followed by the keyword for that. So we're going to put down the mean was different from 5. Whenever I draw out the means, I got a lot of stroke. I have like a lot of problem drawing out all of the Greek letters because the Greek letter is not on my keyboard. Is really hard to type them. It's really hard to draw them on the question. I would just call M's on the question by itself. Sometimes I cannot draw it properly, to be honest. And then the mean equal to 5. Is that good, people? And then this has to be the 2 tau because we have equal to. Is that good? And then we're gonna do for t equal to x bar was 4 minus 5. Okay, and we divide it by 1 point. Make sure that the mean was. This is the mean. We have to take the x bar first. We have to take the x bar, subtract the average, right? So you do not do the opposite for this. And then we get divided by the sample standard deviation is 1.4, and then multiply by radical n. So I use different markers on the exams, and then you should be able to avoid that mistakes. So the x bar always be the thing that I had to put first, and then after that subtract the hypothesized mean. Okay, and then the n equal to 25. We multiply by this radical 25. What do you get? Okay, very good. Oh my goodness, you guys really fast. I love it. And we got the answer is negative 3.571. Yeah, I like that. And it still responds, right? If you need some help, right? So after the semester, let's say you apply for something, you can write you some letters or stuff like that, because I know your name in this classroom, you participated a lot, like Jennifer. Jennifer today is so quiet. Okay, so now we're gonna go for the TC as well. So the TC was what? The TC was based off the DF equal to 19, and then the alpha equal to 1%. Is that good? Right, so now we have to take the absolute value because the t was negative, right? Yeah. And then, so we're gonna go up on the chart, and then let me just look at the 19. Why always 19 degrees? Oh, no, not 1924. Oh my goodness, I'm so bad. The DA was 24. Actually, it's not 19. I'm so sorry. So let me just erase this real quick for that. Where's my erasers? Okay. Yeah, I'm so sorry. It was 24. Okay, so the DF was 24. All right, and what else? Oh, okay, so can I just put it down negative 2.729? I'm sorry, negative 2.797, right? Is that good? Do we have to go to the chart one more times, or maybe just skip it? All right, I'll go to the chart one more time. Just want to make sure we know how to read table 4. And then this is a 2 tau area. We have to work for 2 tau because we test on a difference. And then we're gonna go for Oh my goodness, I want to copy that. 25. So we have to go for 24 degree of freedom. So this is 24 degree of freedom. So we got 2.797. Oops. All right. Is that good, people? Is that good? All right, fantastic. So after that, we're going to compare. This is 1%. We're going to compare 3.5. Yeah, if the t was relatively big that we computed, big negative, big positive, so we're going to accept HA, right? So the absolute value of t is greater than DC, and we're going to accept HA. Okay. Yeah. Oh my goodness, now so when we accept HO, meaning that we reject HO and then we accept HO. Is that good, people? Is that good? Any concern for that? Yeah, even if I take the alpha equal to like 0.0001, like that, I don't think so. Okay, I don't think so. I don't think so. If I take like 99.99%, I'm sorry, 99.9%, I don't think so. I would have to reject. Yeah, depending on the certainty that we want to look at. But I feel like 99% confidence is really, really crazy. Yeah, it's 2.797. That is big. Compared to 5% was 2.064, right? 10% were 1.711. Right. So 99% was really, really tremendous. Yeah. Exactly. It's a different. That's the very smart thing that we're gonna have different. And if you forgot it, that we're gonna put it here different. See that the word different going to be like a two-tailed test, and then the words like greater than or less than or more than, exceed, below. So it's gonna be one tail. Okay. Is that good? Very good. Now we're going to spend a little bit times on 10.2, and I will let you go. Is that good? It's basically going to be like the same concept that we have learned so far from chapter 8. So we're going to be on the proportion.
For the previous question, we accepted the alternative hypothesis, right?
Yes.
Okay, thank you.
You're very welcome. Accept HA, meaning that. So what does that mean by accepting HA? So I would say I am very convinced, or maybe I have enough convincing evidence to say that, well, the average tension for distraction for teenage boy should be different from 5 minutes with 99% confidence. Is that good? This is what we're going to have right there. I mean, we still have to face 1% chains of risk that is might go wrong. There's nothing we can say like 100%. Okay, it's always be like some risk for that. The probability perspective. All right, so I believe hypothesis testing on proportions going to something that we're going to learn. Yeah. It's a point. It's a point. The TC was something that we go for. It's based off the alpha, the chains that we want to look at. If you take 5% chains, if you are willing to face 5% risk, so the alpha is 5%. But if you want to make your report very solid, I would say take 1%. But even with the with the vaccination, like 5% is actually really, really acceptable risk. Like, and if you look at some report, they say, I will be like 65% confident to tell you, oh, 65% is actually a questionable analysis report because it might not be true. Like most of the analysis done on the report is providing very weak evidence for that reason. So in order to be the strong evidence, we have to have at least like 90% confidence, or the alpha that we're facing will be 10%. Okay, so now we're going to go for the hypothesis for proportion. It's pretty much the same thing. How many times did I draw the circle here? you can count them, right? And then, so you're definitely not going to forget the circle. So we have the population. And in terms of the quantitative data set, so the qualitative data. So if you have a chance, you can look at the SPSS, right, like statistical package. So they're actually a big difference between the quantitative and the quantitative report. Okay, so the quantitative data set, they're going to take only a single perspective into account, which is called a P. And then we have for a small sample one more times, right? The sample is, we're going to shed some light from the sample, right? To see what the jungle looks like. The jungle is a whole darkness, right? So we want to see, hey, how is that possible? The sample going to shed some light, and then let me know what inside a jungle, right? What inside a jungle. And then we're gonna call this is a sample, and then of course that we're gonna facing the p hat, and then the p is computed by the number of success over a total number, right? So let's say we're gonna have the p, which is gonna call the population proportion, and then we have the p hat, which is called a sample proportion. Is that good, people? Is that good? So we know how to do this one, right? Yeah, so we know that, oh my goodness, I'm so sorry. So we know that the p hat can be computed by what? It will be the number of people who say yes, right? Over the total sample, right? And then the p was pretty much the same thing, that we're gonna look at the number of people who say yes, but over the big N, but we don't really have that information, to be honest. How is that possible that we can test on the entire population? So over small n, right? And then we're just looking at the Z test. The Z was what? The Z was something that we learned from chapter 8 will be, people, p hat minus, oh my goodness, you guys forget everything after we studied the past 2 weeks. I know it's happening. That's don't worry. I'm gonna remind you again. I just wanted you to do well on the exam. usually I have a very, very fun joke. Like, you know, let me tell you something. After this semester, right after the final exam, I'm gonna throw away all the notes. I will forget about anything. But you have to at least know one thing. This is the picture that I draw. In order to do statistic within a sample collected from the population. This is really important. Yeah, yes, very good. Yes, Sabihar, you have questions? Yeah.
Yeah, so like the formula that you showed us earlier for Z, so that is also called the Z test, and this is also called the Z test?
Yeah, this is also called the Z test. I mean, the Z test can be worked for not only for one proportions, but it can be for 2 proportions and so on and so forth. But I am planning to keep that, to skip that part. So we're gonna take 1 minus p and over n. Is that good? Yeah. And this is have to be the Z test. If you want to know why is follow the Z test, I might have to post some classwork with a certain notes that might help you understand a little bit more why the standard deviation equal to radical p times 1 minus p over n is coming from the binomial perspective. But we skip that part, so we don't have enough time for that. And we're going to leave Z test, right? The Z test does not depend on the degree of freedom, so we have to go for table 3B, okay? Table 3B for that reason. All right, so we're gonna do 1 or 2 questions and see if we can deal with them. It's pretty much the same concept, the same way of accepting or rejecting. So we're going to look at which question that you want to deal with. Can I do question number 1, sir? 1, 2, 3, 4, whatever the question that you want here. Let me just do question number 1 and see what it is. Yeah, in a survey of 1,000 women ages 22 to 35 work full-time, 540 indicated that it would be willing to give up some personal time to make more money, and do the sum of that is whatever it is. So, and then we're going to have the n equal to 1,000. Very good. So 22 and 35, those two numbers are irrelevant to the question. So what we need to have is x equal to 540, right? Is that good? So we can compute the p hat in this case. So the p hat that we have is 540 over 1000. Are we good? Is that good? So we're gonna take the number of people say yes and divide it by the total number of sample, and we got this one equal to 0.54. Yeah. Oops. Are we good with that? And then the keyword for that was, sometimes this question was tricky, but you gotta be careful. What does it mean by the majority? The majority mean what? Anyone knows? People? Majority means what? More than 50%. Very good, Jennifer. Now you're gonna start talking, right? So the majority of the women ages 22 to 35 work full time. And then so we have to put the P greater than 0.5. Is that good? People? Yes. So we have to be careful, right? You cannot put p hat on the hypothesis, because remember that we have to test on the population. So the p hat is the sample that we have already, right? So we cannot say, well, p hat's greater. It's obvious 0.54 is greater than 0.5. So what's the point of testing it? So we test on the population. Remember the p's here is test on the population. So this is 1 tel, right? 1 tel. Are we good? And then we're gonna go for the z. Can I just copy the formulas instead of we just writing it down right here? Can I just copy it from the other side here? I feel like that's a little faster. All right, so we're gonna compute the z. So the p hat that we have was 0.54 minus 0.5. Oh my goodness, now we have a lot of work. But this might be nothing compared to chapter 11. I'm gonna upload it on the chapter summary, because I just don't want to let you see the chapter in the last minutes. I wanted you to look it up maybe the whole, maybe the whole week. And chapter 11 was pretty hard, like in terms of the calculation. So the P was 0.5 times 1 minus 0.5, which is also 0.5, right? Correct? And then we divide it by 1000. Somebody can help so we can end the class a little early. Oh my, Jennifer, now you're gonna start working there. So 2.53, so we divide it by 1000. And then, is that good, people? Did you get the same answers here? Let me just do the math on the calculator. Oh, let me just do it on Coco. It's faster, actually. So we take 0.54 minus 0.5 over square root of 0.5 times 0.5 over 1000. So we got 2.53. Are we good? Any concern for that? Any question? People? Yeah. Because of the majority, yes. It's greater than 0.5. I put it here. Majority is greater than 0.5. Yeah, that one is a tricky question, I believe. It's not quite easy to identify the P in this case. Oh, you thought P was 1000? Oh, come on, it's N, like the number of people, the number of sample, I'm sorry about that. So, and after that, we're gonna go for ZC, right? The ZC was something that from the critical values So the alpha was 1%. It doesn't depends on degree of freedom. Remember, the only thing that depends on degree of freedom, not the only thing, but there are a lot of them, but the Z specifically does not care about how many samples that we have. It's always be the fixed number. So we're gonna go for table number 3B. And then the 3B was here. I'm sorry, 3C, I apologize that I wrote it wrong. This 3B was confidence interval. I'm so sorry about that. Where's my paste? Okay. I'm sorry about that. It should be table 3C in this case. Are we good? So what is the table tells us? What is the ZC here? The ZC equal to people at 1%.
Wait, wouldn't it be 2.33?
Yeah, 2.33. Is that good?
Yeah.
Yes. So which one's bigger? We can do an absolute value, but we don't need to because the value is positive, correct? So it's always correct for that reason. So we're going to say
Accept alternative hypothesis.
very good. Accept HA. Any concern? The hardest part is like to understanding why we have to accept HA or not accepting HA or rejecting HA. So that's gonna be the hardest part. Other than that, we're just doing some math and read the charts. It should be on the right tail because the greater than is right tail. P greater than 0.5 is right tail. The value should be positive. Right tail is positive. Yeah. Draw the diagram. Do you want to draw that? Oh, come on. You know, drawing diagram might be a little bit too much.
Oh no, you don't have to draw it. I said it that in general. Like you could draw in your mind and like it makes more sense.
Yeah, it makes more sense for that. It's definitely gonna be something that we're gonna look at it. And then so 2.33. And then and what else? So 2.53 should be on the right. It should be on this thing. Correct? So 2.53. It's going to be on the accept HA regions or reject HO. Yeah, whatever the term that you want to call it. And it's drawing some diagrams helpful. Sometimes it's on the right tail. You see that on the right tail, so that the value for TC should the value for Z should be negative. I'm sorry, should be positive. I apologize. Is that good? Are we good with that? Oh, hold on a second. Oh my God, I couldn't really. Oh yeah, now I can't pen it anyhow. Any concern for that? Yeah, it's pretty much the same concept. The hardest concept is on 10.1. The other thing just followed through from chapter 11. It's going to be pretty much the same thing, but instead of doing for one sample, we're going to do for two sample, two population. And then chapter 12 is going to be on the chi-square test. This is doing pretty much, it's not the same thing, but it's doing pretty much, using the same concept, the Z greater than the ZC, less than, you know what it is, okay? Is that good? All right, you need one more example. Are we good to go? Always say bye to each other. People? One more. Okay, that makes sense. Yeah, that's gonna be good for that. I feel like having one more example gonna be really, really good that we can see if more than a quarter. So I would be asking you, what does that mean by more than a quarter? And you'd be like, I don't know, it's quarters. And I'm gonna, oh my goodness, you're gonna make me so sad. let me do this question number 3. So now I would ask you, what is more than a quarter? I don't know. You tell me. Yeah, you can't do that on the exam. You have to you know, put them down. So the n was 283, and the x was 74. So I can compute the p hat. The p hat was what? Can somebody help? The p hat was. I know it's 74 versus 2. I need the answers, the decimal point, you know? Oh, come on, you guys, just like, you gotta be kidding me. Just doing all of this math instead of giving me the fraction. I know this is what I told you before. Just leave the answers as a fraction. Good to go. But if you're like looking at 74 over 283, what does that stand for compared to a quarter for that? It's slightly greater than a quarter. So I believe it's 0.261, right? So that's so funny. 0.261. Right. And then after that, I'm gonna put the HO and then H8. And then for that part, we're going to put the P is greater than 0.25, correct? So why is that? Because more than a quarter, right? So meaning that it's greater than 0.25. And on top, it should be less than equal to, but just put the equal sign. I perfectly accept the answers. And oh, it still be the right tail. I was trying to do the left tail area. It has to be one tail. A two tail is going to be the same. So two tail, just look it up a chart. And this is a for two tail test 1.96 and 2.58. Yes, question.
Yeah, how do you know it's dealing with proportion?
Huh? I'm sorry.
How do you know it's dealing with proportion? Because the other problems we use the other formula, right?
Yeah. How do we know it's dealing with proportion? Well, I mean, the questions gives us number of success out of that, and then it's more than a quarter, so it's always in terms of percentage. I believe it doesn't give us the mean and standard deviation, so it's definitely going to be the proportion problem, correct? So the other question that gives us, they give us mean and standard deviation and all of that information, correct? The proportion does not give us that information. Is that good?
Yeah, thank you.
You're very welcome. You're very welcome. So can I just copy these pictures just for easier to compute? All right. Yeah, Jennifer got that part. I'm just 0.446. Let me just do that. Usually 0.261 minus 0.25 over. So let me just change the marker for 0.261. Just want to make sure that we know the difference between the p hat and p, or in different colors. And the p hat was 0.261. Okay. And then we divide it by the square root of 0.25 times 0.75 over square root of 283. Is that good? And then you're going to set that equal to and I know the answer is 0.44. I just want to, it should be very small, but I just want to show you how, so I can copy the calculations on, you know, 0.75 over 283. Yeah, so 0.42, right? 0.43, whatever it is. Is that good? And after that, we're going to look at the ZC. the ZC was something that we're going to look it up on charts. So the ZC was 1% should be on the right toe. 1% right toe was 2.33, also 2.33. And I think I should do like with a difference. So if just looking at a two toe, the two toe was 2.58 as simple as that. And then we're gonna have the Z less than ZC. So we're going to reject actually. Is that good? So again, we can't accept the HO. We have to write fail to reject. You know, fail to do not reject doesn't mean that we're going to accept it. Okay? And that's pretty much the entire lectures for chapter 10. Any other concern for that? Any question?
So you know how basically when we're drawing, right, we care about rejecting the alternative hypothesis or accepting the alternative hypothesis, right? And that's because that's the hypothesis that we're testing, right?
Yeah. Usually,
Okay.
the text they're going to write fail to reject HO, or reject HO instead of their term hypothesis. The reason why we have to put more focus on the HO because it's something that we're trying to disprove and we cannot disprove it. But doing that might be a little bit too long for our class lectures. So I just let you just say reject HA. So reject HA meaning that we fail to reject HO. Okay, so that's going to be the entire story for that. Oh, when in the second exam, you guys just asking like really quickly for that. Come on, give me some time, Villar. The second exam should be what time, people? We're gonna go for the announcements real quick for that. The second exam should be after Thanksgiving. What do you think? You want to do it before Thanksgiving or what? I don't think so. I don't think we have class for that though. I think there's definitely not going to be the day that I'm going to take the exam review on November 22nd. That's a little bit too much for that. After. Yeah, after is okay. All right. The final is close together. Yeah, I mean, the final is, yeah, the final exam and the final review should be close. This is like optional day. You don't have to participate. It's usually after class, we're gonna have the final exam you have to take, and then until next day, until next Sunday, to finish it. Yeah, the second exam gonna work exactly the same thing. So after the exam review, we have 24-hour time frame to finish it. All right, so far so good. Overall chapter, oh no, it's not. I will let you know exactly what topic will be on the final exam. Is the final going to be 8 questions? The final should be it should be around like nine questions actually. You know, the final is the total 9 question for that reason. Oh come on, 6 question was a little too 6 question. Usually if I teach the class, that only an hour and 25 minutes, and then we meet twice a week, so that should be 6 questions. But since we're gonna meet once a week, so we have more times and then we have more questions. I feel like having more questions is a little bit better because if you messed up one question, you don't lose a lot of points along the way. If you have like fewer questions, let's say I give you 1 question only. If you fail 1 question, the finals, the chapter 14, it's not chapter 14, it was chapter 5 and chapter 13, I think so. Chapter 5 and 13 is basically working on the correlation and instead of the thing. So let me just rewrite them 5 and 13. We skipped chapter 5, correct? Because we haven't done it before. It's on a correlation, let's say, between two subjects or two or more. So we have the linear regression model, and then just play around with this. Yeah. Oh my goodness. No, it's actually like, it's still be like 3 hours because the final exam, including some material from the third exam. So the third exam should be a little bit easier compared to, it should be like the same time frame with the same number of hours for that. And I might give you maybe like 15 minutes, additional 15 minutes for submitting work, but generally it's not gonna be 1 or 2 hours. No, we do have classwork. Oh, come on, you guys. Classwork is fun. It's a lot of fun, you know. And I'm gonna give you classwork number 5 or 6. Let me just look at this. Yeah, so let me just take classwork number 6, actually. Yeah, we do have a classwork number 6. Yeah, we can have this conversation after class. All right. I will basically going to give you classwork 6 after class and tell us exactly the question. It should be there, but I don't think so. I don't think that we have it here. Let's just take a look at that real quick. Oh, I think I messed up the side for that reason. Hold on a second. Yeah. Yeah. Oh, this is classwork 5, but we need classwork number 6 for sure. Yep. I'll definitely gonna do that at the end of class. Yes, I want to make it due at 11:59 p.m. Just want to making sure that you guys have enough rest. Right? Don't tell me they're gonna go to sleep right after class. It's not fun. All right, so I hope that you guys are going to enjoy Saturday. And if you have no questions, I'm going to end the class here. Okay, if you have more questions, so you're going to stay and see me at the class. I hope that you guys are going to have a wonderful weekend. So I'll let you out a little early, half an hour early, but remember that we don't have to take any break for that. And I hope you guys are going to have like a lot of fun during the weekends. Take a look at yourself. Bye-bye.